So in this problem, we're given a one-parameter family of solutions, y equals 1 over x squared plus c. And their solutions to this differential equation here, y prime plus 2xy squared equals 0. It says find a solution of the first order initial value problem consisting of this differential equation and this given initial condition. So if you look at this differential equation together with this condition, these two things together is called an initial value problem. So this answer here, y equals 1, let's write it down. Y equals 1 over x squared plus c. This is called a one-parameter family of solutions. So if you solve this differential equation using some math, you'll get this. So we have to find the solution that satisfies this initial condition, y of 3 equals 1/8. So to do that, all we have to do is replace x with x and y with y. So in this case, y is 1/8, and that's equal to 1 over, and then x is 3, so it'll be 3 squared plus c. Okay, so 3 squared is 9, so you get 1/8 equals 1 over 9 plus c. And now to solve for c, what we can do is we can cross multiply. So we have 9 plus c, and that's equal to 8. And then subtract 9. So we get c equals -1. All right, so now what you do is you just plug this c back into your one-parameter family of solutions. So 1 over x squared minus 1. So that would be the answer to the initial value problem. So you would just type that in up here. So x squared minus 1. The next part's a little bit trickier, but it's not too bad. It says, give the largest interval I over which the solution is defined. So to do this, what you have to do is you have to graph this. So to graph this, let me just show you how to do it. So there's the y-axis, there's the x-axis. So the vertical asymptotes are going to come from when the bottom piece is equal to 0. So if you set this equal to 0, you get x squared equals 1, take the square root, so you get x equals plus or minus 1. So we have 1 here, and we have -1 here. And these are our vertical asymptotes. And this actually has a horizontal asymptote at y equals 0. And you can use a calculator, or you can just realize that the degree on the bottom is bigger than the degree up top. There is no x here, so it'll always be y equals 0. And if you plug in 0 into this, you're going to get -1, right? If you have this, if you plug in 0 here, you'll get -1. So it looks like this. And again, I pretty much have this memorized. Again, you can use a calculator, and you will get this. So from this graph, we can get the answer to the interval. So here's how. Our condition was y of 3 equals 1/8. So that means that our point is 3, 1/8. So you have to look at the graph and see where this is. So it's going to be here, right? Because if this is 1, this should be 3, 1/8. And so that tells you that the answer is right here. So it's this interval here. So it would be 1 to infinity. I'll go ahead and type it in. So 1 to, and then I think there's an infinity symbol. If I type in infinity, it might work. Let's see. Yep, it does. So you pick the interval where your point is. So again, our point was here. So we pick this interval. If our point was this one, we would have picked this interval, -1 to 1. Or let's say that our point was over here, then we would have picked -infinity to -1. So you pick the interval where the point is. There's 3 choices here, right? There's this one, -infinity to -1. There's this one, -1 to 1. And there's this one, 1 to infinity. The reason we picked this one is because our point is over here. So it's a little bit tricky. So you pick the interval where the point is. I hope this video has been helpful.